Right after watching this tutorial, you'll be able to train YOLO11 model with your custom dataset. This particular tutorial will take you from dataset preparation, model training, model evaluation, and finally how to test this model with your test set. This single tutorial will take you from dataset to a fully functional YOLO11 model. There is a lot to learn in this single tutorial, so let's get right into it. Before we get started, if you are new here, kindly subscribe so that you don't miss any of my future videos. I've prepared a Google Colab notebook for this particular tutorial, so I'll be taking you guys through, and a link to this notebook will be made available in the video description. When you click on it, you get this exact notebook and you can train your custom model with it. Okay, so first thing first, after getting this notebook, just change the runtime to GPU so that you get access to Google Colab free GPU. So I'll change runtime, and over here I'll select the T for GPU. So I'll save this, and this is going to connect to the Google Colab's GPU. From there, we have to continue to install the libraries. Okay, so you can see over here, you have to install versatility. So just run this cell, and this will go ahead to install this particular library for you. I'm installing it in quiet mode, so you'll not see any drop down here. In case you don't like it, you can remove this flag here so that you see all the installation process. From here, I'll run this cell to import the libraries we'll be using. So we are importing YOLO from authorities, and also we are importing image and display from IPython to visualize our results. So I'll run this one as well, and this will import all these libraries. The next step is to download the datasets. Okay, so the dataset on which you want to train your custom model on. So I'll be using datasets from RoboFlow. So I'll just head over to RoboFlow Universe, and over here there are a lot of datasets. Okay, so RoboFlow hosts a lot of datasets there. So in case you want to train any model, first search on RoboFlow to see if you get already made dataset for your problem. In case there is no dataset, I have also done a tutorial on how to prepare your own dataset and train your model with RoboFlow. So I'll link that tutorial in the description so that you can just click on it and see how you can prepare your custom dataset for training. So after preparing that dataset, you can continue with this tutorial to train your custom model. But if you find your dataset on RoboFlow already, then you are lucky. So let's just continue with that. So once you find your dataset, just locate it and click on it. In this tutorial, we'll be training for fire detection model. So I'll scroll down here, and I wanted to use this dataset. It contains one class, which is fire, and 140 images. So I'll click on it. And because I want the training process to be fast, I'm choosing a dataset with less images. So I'll scroll down here, and you have to just click on datasets. Okay, so when you click on dataset, click on YOLO11, and this will prepare the dataset for you. So there are two options here. You can either download this dataset to your computer or show the code and use that code to download it in Google Colab. So I'll select the radio button, show download code, and I'll click continue, and this is going to show me the code to download this particular dataset in Google Colab. So here is the code, and your API key is here, so make sure you hide it from your friends. For me, I'll show mine because after this tutorial, I'll revoke this particular API key. So I'll copy this code and click on done, and over here I'll go back to this Google Colab notebook and update this with the new dataset. From here, run this particular cell, and this is going to download the dataset in your directory where you are working. So after downloading, we can view this dataset. So our downloading process is complete, and when we click here now, we can see we have our dataset, which is in the folder called Fire2. So this process is also done. I can hide this, and now we'll move on to custom training. So this the only line of code you need to train your custom model, but I'll quickly explain this line of code so that you will not run into any errors in case you are training your own model. So first, we said we want a YOLO model, and the task here is to detect. That's to say we are training an object detection model, and the mode here is training. So we want to train. Okay, so the mode is train. We have predict. The mode, you can send it to predict or eval, but in our case, we want to train. So we've set this mode to a train. And then the model we want to use to train, which is the pre-trained model we want to use. In this case, we are selecting YOLO11N. So I told you in my previous tutorial that YOLO11 comes with 5 different pre-trained models. We have YOLO V11N, which is the Nando one, YOLO V11S, YOLO V11 medium, YOLO V11 large, and YOLO V11X. But in this case, we'll be using N. In case you want to use X, you just have to change it to X. In case you want to use the medium one, you have to change it to M, and so on. But let's change our own back to N, since that's the model we'll be using. And this model is very fast and it has less parameters. So the data here, you have to give the path to your data set. Okay, so this will lead to the path to your data.yaml file. But pay attention, before you give this path, there is one or two things to do. And make sure you do the same thing, because if you don't, you run into an error. So let's go back to our data set, and when we open this data set folder, you have to scroll down and open this data.yaml file. So once it's open here, we have to update this path here so that we don't run into error when trying to train our model. So over here, come back to the train folder and open the train folder. Make sure you locate the path to the images. So over here, just click here and copy the path to these images and use that path to update the train here. You do the same thing for the rest of them. So you open test2 as well, locate the images folder, copy the path and update it here for the test images. And lastly, we'll do this for the validation images as well. So we have to copy the path to these images and we have to use it to update this one as well. Right from here, you can hit Ctrl S and this is going to save this back, and you can close this and you can also close this as well. So let's hide this. So now data should be equal to the path leading to your data.yaml file. So let's go back to the data.yaml file right here and let's copy this path. So let me do it once again. Copy the path right here and we can close this once again. So now I'll update this new path with this particular one. And then now we have the new path to our dataset. Up next is your epochs. So the higher the epochs, the longer it takes to train and the better the model. So in your actual world scenario, you can put a higher number here for your epoch so that your model trains for a longer period in order to get a good model. But one thing I like is that no matter the number you put there, when the number is high and you are training and the model is not improving, YOLO V11 have early stopping feature that will stop the training automatically and save your model for you because there is no improvement over time. So for me, in this case, I'll just leave it at 80. I'll leave the image size to at 640 and the plot is also equal to true. But you may have to change your epoch to a higher number in order to get a very good model. Since this is a tutorial, I just want to teach you the training process and how you can easily and effectively train your custom YOLO V11 model. So I'll hit run here and let's see how the training process will kick off. So now it's scanning all the images in our various folder and it's going to start the training process very soon. Okay, so our training process have begun and you can see we have 1 out of 80 epochs. So this will run to 80 epochs, or maybe early stopping can kick in and it will stop. So I'll see you guys right after the training. So the whole training process is done and our results now are saved in folder called runs, detect and train. So when I click here, now you can see we have a folder called runs. When I click on runs, it will open, you have another folder detect. And then when you open train, you can see we have all our graphs and the model weights. So when you open the model weights, you can see our pre-trained model will be here. We have two pre-trained model. We have best.pt and last.pt. So your best.pt is your best performing model and your last.pt is the last trained model. So if you want to use this model, you can test both of them, but it's always advised to use the best performing model. Okay, so from here we have to access some of these graphs and visualize them and see how they look. So you just have to copy the path to these graphs here and then you can visualize them. The first graph we want to visualize here will be the result.png. So it's over here. I'll just have to copy it and replace it in this path here, and this will visualize the results for me. So I'll click run and this will run and display that particular graph for me. So you can see how it goes. You will see your validation loss and all other graphs you want to see. So the metrics is also here, precision is also here, and every other thing you want to see in the graph is here. We also love to show the F1 curve. So I'll just put the path here, and in this path, after running it, it will show that graph as well. So this is just to display some of the graph for the model. You also have the PR curve here. So if you want, you can also show that particular graph. From here, the next step is to validate this fine-tuned model. So you have to validate it to see its overall performance. And to validate this model, you have to first update the path to your model. So this is the path to my model. In case you want to get the path to your model, you can see we have weights, and inside weights, you can choose any of those models, either best.pt or last.pt. Close this sidebar, and over here, model is equal to, then you give it the path to your model. And also you have to validate it on your dataset. So you have to replace this one with the path to your dataset. So I'll go back, and inside file 2, I'll open that folder, and I'll copy the path to data.yaml file. So I'll just locate the data.yaml file, and over here I'll copy the path, and this is the path to my dataset. And make sure you just update data is equal to, and then you put the path to your dataset. When you paste this here and you run this cell, this is going to validate your model, and the results will also be saved right in your working directory. So your model has been validated, and the result is saved in runs, detect, and val. So when you open here, you can see when you open runs, detect, and we open detect right now, we have validation. So here, when you open validation, you will see this validation graph and validation curves. So you can open them and see how well they perform. But for now, we just continue with this tutorial. From here, the next thing to do is to run inference with your custom model you've trained. So you have to run inference on the test images to see how this model you've trained will detect objects in these images. So I just have to update this path here, and then this model will run inference on all the images in the test set. For that, you have an instance of YOLO, and the task now is equal to detect. The mode is predict. We are not training this time, we want to predict. And then the model, this will lead you to the path of the model. So since we have done it here, I'll just come and copy the path to the model and update it right here. Then from here, I will leave everything like this. What I'll also do is to go to my images and copy the path to the test images, so that it will run this test on all the test images, so that we can see how well it will detect objects in the test images. So I'll just copy this particular path, and I'll update it right here. Okay, so after updating this path, now we can run this cell, and this cell will run inference on all the images for us. Okay, so after running this inference, now we have to access these images and display them, so that we can visualize how it has been able to detect the object on them. So they said the result here is saved to runs, detect, and predict. So when you come over here, we can still open our runs folder, detect, and we have to get the path to this predict. Okay, so when you open predict now, you can get access to the images it has run this test on. So over here, I'll just change it to predict, not predict 2, and then the path will be all right. So after running this, I expect it to read all the images in that particular directory, and also visualize how well it has detected fire. Okay, so you can see the results. It has detected fire over here. It has detected fire. It has also detected fire over here as well. All right, guys, so this is how easy you can train your custom YOLO11 model using this particular Google Colab notebook. The whole process is easy because you guys have to just give part to your data set, and everything is going to be handled for you. I never expected this model to even perform this better, because we've just trained for 80 epochs, but at least it's able to detect something. So that's to say YOLO11 is very good and is able to work well even though we've trained for 80 epochs. So let me have your thoughts in the comment section. And also, if you have watched up to this point, thank you so much for watching this tutorial. So that's all for this tutorial, guys. Let me have your thoughts on this tutorial, and also don't forget to share this tutorial with someone. Thanks for watching once again, and I'll see you in the next tutorial.